Next up, question 5 says a ball is thrown upward to a height of h sub 0, which is equal to 5 meters. Each time the ball bounces, it rebounds to a fraction of r, which is equal to 25% of its previous height. Let h sub n denote the height of the ball after the nth bounce. Write out the first 4 terms of the sequence h sub n, where the index n here starts at 0. And then it asks, is this a monotonic sequence? And what's an upper bound of the sequence? Or this should say, what is an upper bound of the sequence? And then lastly, what is the limit of the sequence? All right, so you can see in this figure here, okay, the ball is thrown upward from some initial height, which we're not told, but we're not going to need to know what it is anyways. But it's thrown up to a height of 5 meters. And then it's going to come down and bounce, and then it's going to rebound to a height that is 25% of this initial height. So the height after the first bounce, which is what we're calling h1, that's going to be 25% of h sub 0, right? In other words, 0.25 times h sub 0. All right, then the height after the second bounce, it'll rebound to h2, right? And that's going to be 25% of h1. And then the third rebound height, h3, that's going to be 25% of h2, so on and so forth. All right, so to write out the first 4 terms, right, what we're doing there is just repeatedly multiplying by 25%. Okay, so a couple ways to say that. One is just to say, well, I'm starting with a height of 5, multiply by 0.25 to get the next height there, the h1, which is 1.25. Multiplying by 0.25 again, I'm really just multiplying the 5 by 0.25 squared, right? And that's going to give us a height of 0.3125 meters. Do it again, you get 5 times 0.25 cubed, okay, so on and so forth. So the explicit formula, which I include down here for h sub n, is just the initial height 5 times this 0.25 multiplier raised to the n power there. Now, as a recurrence relation, what I included here, this is just saying, okay, to go from the nth rebound height to the n plus first rebound height, just multiply that nth height by 0.25. That's what we call a recurrence relation. But in any event, there's the first 4 terms. Now, is this a monotonic sequence? Yeah, you bet, right? Since we're repeatedly taking 25% as we go from term to term, clearly the heights are decreasing there, and so this is a monotonic decreasing sequence. Then it asks, what's an upper bound of the sequence? Well, that would just be our initial height, right? 5, because we're bouncing from 5, and then we're just again seeing all of these successive heights where we're just repeatedly multiplying by 25%. So I note here, right, all of our heights are between 0 and 5 inclusive. So in particular there, that initial height serves as an upper bound for the sequence. And then lastly, it says, what's the limit of the sequence? Well, technically speaking, according to this model, we're never actually going to have 0 as a term in the sequence. Now, of course, the height will get infinitely small as I let n get sufficiently large, but we won't actually hit the ground. Now, you know, for practical purposes, of course, the ball will stop bouncing and it'll just sit on the ground. But as far as the limit goes, the sequence, right, as I let n become infinitely large, right, this factor 0.25 to the n approaches 0, and so this nth rebound height, of course, will approach 0. Okay, so on this note of limits, in the next video, next couple of videos, actually, we're going to start talking about limits of sequences in a much more formal way, and so I will see you there. All right, thank you so much.